Hello everyone, this is Professor Lee again. We are going to continue to investigate probability topics in this course, which is in chapter 3. Now, what we are going to cover today is chapter 3.4, and it's about contingency table. So this is more like actually a question, a problem analysis than the content analysis, right? So we learned the concept of and, or, mutually exclusive, independent, dependent, all kinds of things from last two chapters. And this chapter is actually how do we actually apply that type of concept in a question, especially the question has a table form, right? Contingency table. So, without further explanation, let me just give you an example. Well, let's talk about this example here. So this table, you can definitely guess the name of this table, right? This table is called contingency table. And it gives us all kinds of information. And this table is really about, speed violation, and it's about the cell phone use while driving and how do they relate it to each other. So this table describes speed violation and whether they are using cell phone or not. So according to this table, how many people actually altogether participated in this, study? What do you think? What's the total amount of people? Well, it's right here, right? So 755 people participated in this study. And if you take a look at this table, let's say this 25, this number right here, what does that mean? Now, 25 of them used cell phone while they are driving, and they also had a speed violation in last year, right? Very bad combination, I guess, right? And this number right here, 280 people, they used cell phone while they were driving, but they didn't really get any speed violation last year, right? So that's what this number stands for. Now, if you're just interested in how many people actually used cell phone while they're driving, I guess you just need to add these two, and then you get 305, right? So 305 used cell phone while they're driving. This next line, anyone in here does not use cell phone while they're driving. Amongst those who did not use cell phone while they're driving, yet they got speed violation last year, was 45. Now, then majority of them, right, they did this number, 405. These people didn't use cell phone while they're driving and didn't have any speed violation last year, right? That's what this number is for. So if you add these two numbers, and then of course you get this number right there, 550. Now, if you're just interested in how many of them have speed violation last year, then you add these two, right? You add these two and get this number, right? So 70 of them got the speed violation last year. And if you're just interested in how many of them actually did not get the speed violation, you just add these two, and that's what you get. So this 755, you can either get this by adding these two together, or you can get this by adding these two together. So this table, contingency table, it gives us, all kinds of information regarding these two topics, speed violation and cell phone use, right? Okay, So let's say the first question is asking, find P. Now, what do you think this P is? It's a probability, of course, right? What's the probability if you, so the story goes like this. If you pick one person who participated in this study, what's the probability that person used cell phone while they were driving? Used cell phone while they were driving. So altogether, how many participated? 755. Out of 755, how many of them used cell phone while they're driving? Right here, 305. So total number of study who participated, 755. Number of cell phone user, 305, just like that. Now, this question is not saying that you put your final answer in reduced fraction form or get up to 3 decimal or put it in the percent, whatever. So they didn't really specify anything like that. So if they don't say anything, then you can just leave it like that, right? You can just leave it like that. And what about this one? Find the probability that driver had no violation. I guess this is a speed violation, right? No speed violation. Okay. So how many of them did not get speeding ticket last year? No speeding ticket. How many out of total? Out of, again, 755 total, this many, right? These are the proportion of people that didn't get any speed ticket. So it's going to be 685 over 755, just like that, right? So, just, take your time and think about this, So just finding cell phone user, I mean, this is the total right here, the cell phone user total out of total 755. And if you want to know the speed violation, this is the speed violation total right here, 685 out of 755, just like this, right? Okay, moving on. Find the probability the driver has no violation. I mean, when they say violation, that means a speed violation, right? No speed violation last year and was using cell phone. Remember, this is and problem. Okay. So remember in our last class, we talked about probability of A and B. This was what? This was multiplication rule, remember? But we have to consider that in a conditional probability setting. So it gets kind of tricky. But let me give you a shortcut in this contingency table. So I want you to listen carefully because it'll help you to do the quiz. It'll help you to do all those exams, right? In contingency table, this is very, very easy to spot the AND question. It's very easy to spot this AND question. Why? Because this should be the cross section of no speed violation and cell phone user. So no speed violation is here, right? This is no speed violation. And using cell phone user is here. This is cell phone user. So which one has speed violation and cell phone use at the same time? This one right here. This one right here. So answer is just going to be 280 out of the total. I mean, you can still calculate this with using multiplication rule with the conditional probability. However, you don't need to do that in contingency table. For and question, you can just go straight to that. The cell that explains the both condition, no violation, no speed violation, but use cell phone. No speed violation and use cell phone right here. Okay. Now, this one is slightly similar but slightly different, as you can see. This one is find the probability that cell phone user or, remember the linking word here is or the driver has no violation last year. This is an or problem. So, you know, if it's a mutually exclusive or problem is simple addition question. If it's not mutually exclusive, then you gotta subtract. You gotta subtract what? The probability of A and B, right? Let me rewrite it or question here. Let's say probability of A or B was what? Probability of A plus probability of B minus probability of A and B, right? That was the OR formula. So let me give a little bit of time that you can think about this, right? How do you, at least just put it in the formula, right? Let me give a little bit of time. So you can say cell phone user as like, CR or CU or something like that, and no violation as NV if you want to, right? Okay. So how do you do this? You can say something like this. Probability that it's going to be cell phone user or no violation is going to be probability of cell phone user plus probability of no violation minus probability of cell phone user and no violation, right? So this one right here, this is the probability of cell phone user. How many of them use cell phone? Look at the table right here. How many of them use the table? Means use cell phone. Altogether, it's going to be 305. Out of how many? Out of 755. So out of 755, 305 is going to be probability of cell phone user. What about this one, the second one? That's a probability of no violation. How many of them didn't get any speed violation? Right here. So this would be 685 over 755. So this would be probability of no violation. Minus. How many of them are what? Probability of cell phone user and no speed violation. Cell phone user. I mean, we have that probability right here, right? This is cell phone user and no violation. Same thing, right? Cell phone user and no violation, or no violation and cell phone user. So cell phone user is right here. No violation is right here. What cross is right here, 280. So it's going to be 280 out of 755. Now, is it always out of 755? Yes, because 755 is indeed the total number. right, is indeed the total number. So it's always going to be 755 right there. So 755, just like that. So how do you actually calculate this? How do you calculate this? You know what? Let me clear this. I think I have to get out first. And discard and go back in. Okay, so how do you actually calculate this? Notice that the denominator part are all the same. It's all 755. So let me rewrite it here. Then you can just combine everything with one denominator. Then you only need to deal with the top, which means 305 plus 685 minus 280, right? Why is it minus? Because that's minus right there, right? Because that's minus, is this minus. So, if you just type it up, 305 plus 685 minus 280, then what you get is 710. On the bottom, 755, just like that, right? Just like that. So this is a typical contingency table type of question, right? Okay. Okay. All right. So let's move on. This is not a different question. Same question. Cell phone use and speed violation again. Now look at this next question. This next question is that find the probability that driver use cell phone given, notice that given that driver had a speed violation last year. Now this is what? This is conditional probability. Remember, this is a conditional probability. So you can rewrite it like that. Probability that driver is a cell phone user. See that bar right there? That's a given bar right there. Given that driver had violation last year. So how do you actually do this? How do you do the given question, right? Let me give you a little bit of time. You think about it, right? How do you? Well, let me give you a formula though. If we had the probability of A given B, what was the formula? What goes under? The given part goes under. So probability of B goes here. And what do you write on the top? Well, probability of A and B, right? So this was the formula. So if you have, this situation, what goes where and what we need to figure out. So let me give you a little bit of time, and you try to write it down, and we'll check the answer together, right? Go ahead. Why don't you go ahead right now, right? So we are saying that this is like for the first part, and this is the given part. So what goes under? The given part goes under, right? Okay. Okay. So if we rewrite it, the given part, driver had no violation last year, goes under right here. And what goes to the top? What goes to the top? Probability of A and B. So driver use cell phone, and remember this is going to be and. Why? Because this is that and right there. And driver had no violation last year. Okay. Well, take a look at this formula and you tell me what's not exactly same as the formula that I wrote above. right? What exactly not same as the formula that I wrote above. Right? Did you see that? Can you see it? Yep, some of you already see it, right? N, not P, but N. And this is not a typo. This is not mistype. This is a correct typing right there. So what's this N? N means just the number. Meaning, when you are dealing with the contingency table type of question, you can rewrite this formula as N of B. That N means how many of them is in B, N over A and B. So that P, you can rewrite that as N, and N refers to not necessarily the probability, but the actual number. Meaning like this. How many of them are using cell phone and had a speed violation? How many using cell phone and speed violation? This. The top part is going to be 280, just like that. What about the bottom? How many of them had speed violation last year? How many of them had speed violation? Oh, no. Made a mistake, right? This is had speed violation, not this, but this, right? This is how many people that used cell phone, this first part, and had speed violation, So, which is this part right there. So the top number must be 25. What about the bottom part? How many of them had speed violation last year? How many in total? Total 70 right there. And that's the answer. I mean, that's the answer right here. Right? That's the answer. So 75 is the one. I mean 25 out of 75 is the one that we are after. So this contingency table for the conditional probability question, instead of using P, we can actually use this formula as well, which is just taking the number. Now, can we still use this probability formula? Yes, you bet you can. Right? You still can. It'll be just a slightly different form. But I would definitely recommend you to just use it. If you use this original probability form for this question, that would have been finding the probability of cell phone user and had violation. So it's going to be 25 out of 755 on the top. And the bottom part would be probability of violation. So it's going to be 70 out of 755. And you have to deal with this form, fraction over fraction form. I mean, it's not super crazy difficult. You just write this part first. 25 out of 755. And then you write this one as a multiplication, but you gotta flip this top and the bottom. So 755 goes on the top and 70 goes on the bottom, and these two cancels out, and you end up getting the same answer, which is 25 out of 70, just like that. But you know, if this fraction over fraction kind of bothers you, then you don't need to go this way. You can just use this total number, and that will give you the exact same solution, just like that. Okay. Now, let me give a little bit of time and try this question. It's the same question, exact same format, right? With different things that they're asking, but you can use the same technique that we used in the previous example. So let me give you a little bit of time. Why don't you try it right now? Why don't you try it right now? Right? Don't just sit there and do nothing. You gotta try this, right? So this is the case that the driver had no violation last year, given that not using cell phone, right? Not using cell phone. Okay, so we can rewrite it like that, right? Driver had no violation last year, which is this first part, given, so that bar right here is the given part. Driver not using cell phone, this is the second part. So remember that formula that I gave you before, right? Probability of A given B is the same thing as probability of A and B over probability of what? The given part goes under probability of B. But you can also use this formula when it comes to the contingency table. Instead of using P, we can use N for number, A and B, N of B, right? So this we can rewrite as, this P that we can rewrite as N, how many of them? No violation last year and not use cell phone. Given the bottom part, denominator goes N again. What goes under the given part? Driver not using cell phone goes under right there. Okay, so let's think about it. How many of them had no violation and not used cell phone? No violation is right here. No violation, right? And not used cell phone, like this. So the top number is going to be 405. What about the bottom number? How many of them, driver, not used cell phone? Not used cell phone. Not used cell phone total number is right here. 450. Right there. And that's our answer. That's our answer right there. Right? Okay, so this is not super crazy, right? This is not too bad. Right? This is not too bad. Okay. Let's try another example. And this is like, you know, similar example. And this is those Titanic survivor describing table, right? I'm not 100% sure. This might be the historical data. So total passenger of 2,225. Amongst them, 1,690 were male, adult male. This is adult male. And 425 was adult female. And 109 was children, right? And when it comes to survivor or who died, 711 survived. And more than twice of that, 1,513 of them actually died in the Titanic incident, right? Okay, so what's the probability that passenger survived. A little bit of time. Try it. What's the probability that passenger survived? Out of total how many? 2,224. How many survived? 711. So just like this. 711 divided by 2,225. This question, they put it in a decimal number with 3 decimal places. Right? Okay. This next question. So if you select one person, what's the probability that that passenger was a female? Right? Female adult. Right? So how many of them female altogether? Right? You see it, right? Right here. Out of total how many? Right there. So 425 divided by 2,224, just like that. So about, 0.191K. What's the probability the passenger was a female or a child? See that linking word or was it a multiplication or was it addition? Yes, it's addition, right? So addition question. So, female or child. That means, we had this probability of A or B is equal to probability of A plus probability of B minus probability of A and B. Same deal, right? It's a female and child, the same deal. It's the exact same format. So we need to figure out the probability of female. I think we know that, right? It's going to be, we had it right here too, right? 425 out of 2,224. What about child? Child is right here, right? Or how many of them are adult, female, and child at the same time? Well, that must be 0, right? That must be 0. So that must be 0 like that. So this is probability of female. This is probability of a child, of course. So since we have common denominator, combine it. All we need to do is just adding these two numbers, which is what we have here. Type it in your calculator. Boom. That's it. So this contingency table is not that bad, right? It's not that bad, not that big of a deal. If you know exactly what to do, of course, but I would definitely suggest you to repeat these two questions many times, right? So that you feel comfortable, because your quiz question is going to be almost the same question. Almost the same question. Okay, what is the probability that the passenger was female and survives? Remember, this is and question. Now, what did I tell you about the and question in contingency table? What did I tell you about the and question in contingency table? All you need to do is spot that cell, female and survive. How many? Can you see that number? I see right there, female and survive. I see right there. Right there, right? 316. So that's it. You can just spot this out of the total. Type it in your calculator, then you get this answer. Didn't you say and was multiplication question? Yes, I did. And can you still use that technique? Yes, you can. But you have to be careful because this will work with the conditional probability. You got to figure out all that. But when it comes to contingency table and question, you don't need to go through all that. All you need to do for and question, just spot that cell. Where is it? Well, that cell is actually right here. Done. So that's it, right? Okay. Okay. All right, let's move on. What's the probability that it's going to be female and child? Is it a trick question? Well, yes and no. Can you be adult female and child at the same time? No, not in a common sense. So answer must be equal to 0. Right? You cannot be adult and female and child at the same time. That's not possible. Right, what's the probability the passenger is going to be male or died? Male or, this is or question. Or question is what? This or question is going to be probability of male plus probability to die minus probability of male and die. So again, let me give a little bit of time. Try this right now, right? Don't wait, right? Try it right now. While you are with me, we'll try it right now, right? Like I said, mathematics is not a spectator sports. You will not enjoy it by watching it, right? You gotta do it yourself, and it'll come handy when it's time to do the test and the quiz, right? Okay, so write it down. Probability of male. How many of them are male altogether? Number who died altogether. Probability of male and die. Right there. So, probability of male. 1,690 over this number, right? The total. Probability died, right here, 1,513 over the total. How many of them are male and died? A lot of them, right? Right there, right? 1,013, 1,352, right there. Since we have all common denominator, all you need to do is dealing with the top. So this plus this minus this. That's what you get. Type it in your calculator. Boom. That's what we get. That's the answer. Right? Okay. Okay. If a female passenger is selected at random, what's the probability that she survived? Now, I want you to read this question carefully and tell me what you think this is. If is what? If is a conditional probability, right? It's a conditional statement. So if a female passenger is selected at random, that's a conditioned part. Or that's a given part. What's the probability that survived? So survived goes first. We have a condition given. What's the condition? It's gotta be female, right? So this G is a slightly different format, and this is how we interpret and write, right? This is how we interpret and write. So how do you interpret this? Then this is a conditional probability. So probability of survived and female goes on the top. And what goes under? Probability of female goes under, just like that. Now, remember in the contingency table question that P, we can exchange that to N, and we just simply need to count how many. So how many are survived and female? Survived and female, where is it? Right here. 16. How many of them are female altogether? Right here, 425. So it's going to be 316 on the top, 425 on the bottom. Type it in your calculator, and this is what we get, just like that, right? You know, if this is so confusing, I'm sure this is confusing for many of us. You gotta repeat this lecture note with the PowerPoint and take your time and make sure that you get this. Because I'm going to put this question in the midterm and possibly the final and possibly in our quiz as well. You know, similar question. I mean, in this chapter, there's nothing else but this, right? This contingency table. So, and this is very typical, easy question that they always like, right? Okay. Now, I'm not going to say anything. Why don't you go ahead? This is exactly the same as the previous case. Why don't you go ahead and try this? Right? The first part is a given part. I'm not going to. Okay. Go ahead and try it. Try it right now, right? I know some of you are just sitting there or writing, you know, just lying down on the bed. You know, that's a dangerous position that you are in. I'll tell you what, that's a very dangerous, right? You know, if you're lying down and just do nothing and just watching me do this, there's a good chance, there's a good probability that you have to see me again or some other professors teaching the same course. Do you really want to do that? Right? You don't want to do that, right? So why don't you just work with me, right now, and just let's do this and get it over with, right? Okay. See, if child passenger, that's a given part, right? That's a given part right there. What's the probability the child died, right? Conditional probability. So, how do you interpret this? The given part goes under probability of child, and probability of died and child goes on the top. And like I said, that P, we can replace that with the N for the contingency table question. It doesn't work if it's not contingency table question, right? Because you don't have that number. But if it's a contingency table question, then you can replace that P with N. So how many of them died and child? Died and child? Right here, 52. How many of them are child altogether? Right here, 109. That's it. That's the answer. So 52 divided by 109, type it in, calculator, boom, that's it. This is, again, another conditional probability question, but this is more traditional format. So again, let me give a little bit of time. Try right now. Passenger is survived given that it's going to be male. Right? Survive, given that it's going to be male. Right? So survived, given that it's going to be male, just like that. So what goes under? The given part goes under. What goes on the top? This and this. Survived and male. Again, if it's a contingency table, we can change that P to N and just count the number. So how many of them are survived and men? Well, not that many, right? Not that many, right here. How many of them are female? I mean, the male, right? 1,690. So 338 divided by 1,690. So that's 20% right there. So if you're a man and you know, in that boat, in that Titanic, then you only have 20% chance that you will survive, right? If you're a man, right? Okay, so that's the wrap for this chapter.